Hello and welcome to the Art Astra podcast. I'm Emily Olsen.
And I'm Alexa Erdogan.
Today we have a special duo episode discussing some especially creative applications of space science. As we come into 2024, NASA's Artemis missions are gearing up to send astronauts back to the moon. ESA, the European Space Agency, has been working on the PAVER missions, in which they are working to design roads for human life on the lunar surface. With all of this in mind, and with the recent summer cultural phenomenon that was Barbie, Alexa, when you teased this story you're going to talk about, it sounded especially timely. And once we've explored our lunar material Barbie world, I will share a story I recently learned, but has been happening for years now, about how Hubble astronomers helped the whale shark conservation community, and talk a little bit about NASA's PACE mission, which is launching February 2024. Alexa, would you like to take it away?
Yeah, so going back to the moon is no trivial task, of course. It's going to take a lot of careful calculations, some well-designed systems, and some brave and adventurous souls. Among all the considerations that need to be taken into account, one that may surprise you is something very small, but very frustrating. Dust, or more specifically, lunar dust. So lunar dust is essentially defined as the finest parts of lunar surface material. And it's made up of things like rock chips, mineral fragments, impact/volcanic glasses, these things called agglutinates, which are a combination of both mineral and glass. And lunar dust is very, very small. So it's smaller than a human hair. So a human hair is about like 100 microns. Lunar dust on average is about 72 microns. Compared to like regular household dust that you might experience on Earth, lunar dust is unique in the fact that it has really irregular shapes. So it can be sometimes a little bit spherical, but most of the time is angular and sharp. And if that wasn't enough, lunar dust is also electrostatically charged, and it can get worse during the daytime because of the UV radiation. So what that means is, you know, if you've ever like taken a balloon and like rubbed it on your skin and then it like sticks to you, that electrostatic charge is essentially what's going on with lunar dust. So you can imagine how much of a nightmare that can be. You have all this angular, sharp dust that's just clinging to you. And especially if you're near the sun in the daytime, it gets even worse. Historically, there have been a lot of problems with lunar dust and equipment and astronaut health. Emily, pop quiz for you.
Oh no. Put me in, coach.
Do you happen to know of any like stories or historical problems with lunar dust?
I remember that lunar dust was a greater problem than anticipated in all of the Apollo missions. However, Apollo 17 especially, because the Apollo 17 mission was December 1972. The mission commander was Gene Cernan, and he was on the lunar surface with lunar module pilot Harrison Jack Schmitt. On their first out of 3 EVAs, Gene Cernan had a hammer in his suit pocket, and it nicked the right rear fender of the lunar rover, and the fender came off. And it got to be a huge problem. It was causing rooster tails, is what Evans and Cernan were referring to it. It was kicking up all this dust that was getting all over their equipment. In addition to what you outlined earlier, the other issue with the dust was that it was absorbing all the heat and leading to the risk of equipment overheating in the sun. They ended up fixing it after they returned from the EVA, just absolutely covered in dust. While the astronauts were sleeping, the mission control devised a system in which they could use 4 of the 20-something, I think 28 lunar maps that they had to make a replacement fender and attach it to the rover. That's how they fixed it. And it was okay to run the next 2 EVAs with this just kind of jerry-rigged lunar map and duct-taped lunar rover.
Amazing.
And you can actually see 4 maps at the Air and Space Museum. I don't know if they're on view now with the renovations happening, but they're in the collection at the Air and Space Museum, so you can see them.
That's cool.
Yeah. And then, also, sorry, this is more in depth than you wanted to know.
No, I love it. You're acing this pop quiz right now.
In addition to the Apollo program having their own troubles with lunar dust, the Soviets had difficulty with lunar dust as well, specifically Lunokhod 2, which at this time I think is the last human-made rover to be driving around on the moon. They launched the month after Apollo 17. Lunokhod 1 had lasted, I think, almost a year, but Lunokhod 2 only ended up lasting about 4, maybe 5 months. It was suspected that part of its early demise had to do with lunar dust getting into the radiator and having the vehicle overheat. In 2018, there was a report that was released that detailed also some communications problems that the rover was experiencing, but it's believed that lunar dust also contributed to its death. Poor thing. And the reason why I know so much about the Lunokhod 2 is that the rover and the lander that brought it to the moon, Luna 21, was actually, they were both consigned at Sotheby's in the Sotheby's Russian space auction in the 90s. The company that manufactured both spacecraft, Lavochkin Scientific Production Association, sold them both at Sotheby's, sold the legal title. Both spacecraft are still on the moon, but they were sold at auction. And there's a really cool New York Times article about this from, I think, 2010. I'll definitely drop it in the show notes for anyone who's interested. But lunar dust has been a problem for literally decades.
Yeah, no, you aced it. Bonus credit, bonus extra credit.
Something that is both normal and possible to achieve.
Absolutely. Like the Apollo 17 example that you brought up, there's this incredible picture of Eugene Cernan, like back in the lunar module, just covered in lunar dust. It's like, it almost looks like he went exploring in a coal mine. It's just like everywhere. But the amount of problems lunar dust can cause for your equipment, but also for your health, like they were inhaling all of these sharp electrostatically charged particles. And obviously not a great thing when you're trying to go back to the moon and establish like a long-term presence. So there's a lot of research right now that's going into different types of mitigation techniques for lunar dust. And you can essentially think of them as part of three main categories. So there's things like architecture. If you want to design like a lunar habitat, you can put some effort into designing airlocks and scheduling EVAs. So those are extravehicular activities, any kind of essentially like expeditions when you're going outside of a module onto the lunar surface. You can think about these in a way where you're limiting the amount of exposure you have to the lunar dust. And your airlocks are also designed in a way to minimize the amount of dust you're tracking into like your habitation modules and things like that. So generally, just like things like architecture can be great mitigation techniques. There's also passive and active technology. So passive technology includes things that you might think would belong in that category, like coatings and filters and even brushes, although brushes can be pretty abrasive if you're using them on things like spacesuits. They're going to highly contribute to the degradation of your spacesuits if you're constantly brushing them. But things like filters can help in habitation modules, but they are not going to be your standard run-of-the-mill filters either, because they're also going to degrade pretty quickly because of the lunar dust.
Wait, sorry, can I ask a quick question?
Go for it.
What about the brushes would damage the spacesuit? Is it just that the dust itself is so abrasive?
I believe it's the type of bristles that are used on the brush. Mm-hmm. And just like how sensitive the spacesuit fabric is, that amount of like abrasion, and also the lunar dust, because you're like, yes, you're brushing them off, but you're also like physically pushing those particles against the fabric. Okay. So yeah, it contributes to rapid degradation.
Okay, cool. Good to know. Thanks.
Yeah, you're welcome. But yeah, so there's passive tech, and then there's also active technology, which is the most exciting. Things like developing vacuums to suck up lunar dust, developing electrostatic shields, which sounds like so sci-fi and so cool, where you can essentially repel or like zap away lunar dust, taking advantage of the electrostatic charge of the dust, utilizing compressed air. So, you know, like those cans that you can buy to kind of like blast your keyboard of like dust particles and things like that. Imagine something like that, but like cooler and for lunar dust. And then there's also my personal favorite, liquid nitrogen. I know you mentioned Barbie at the beginning. Hang on to your seats. We're going to get around to the Barbie very soon. So liquid nitrogen is a technique that has been heavily researched and being developed by Washington State University out here in the Pacific Northwest. And they are taking advantage of something called the Leidenfrost effect. So what is the Leidenfrost effect? You know, when you have a pan on the stove and it heats up to a really high temperature, and then you take water and you sprinkle it into the pan, and you see little droplets of water just like going around the pan. They don't actually like dissolve into liquid, or they don't form a liquid surface. That's essentially what that effect is. So when you have a liquid that comes into contact with a surface that is so far above that liquid's boiling point, essentially like the outside layer of that droplet forms a gas, it evaporates and creates like a bubble of gas around the liquid droplet. The same concept applies to liquid nitrogen. So the folks in this lab were noticing one day when they were trying to clean up their workspace with liquid nitrogen that they were actually able to blast dust off of the floor of their lab with liquid nitrogen. And someone had an aha moment and was like, wait, what if we could use this, but for the moon? That's probably not a direct quote, but but still applicable. That's essentially what they started doing. So they thought, okay, we could harness this advantage of liquid nitrogen and use it to essentially pick up dust and transport it across the surface. What they did was they took a look at a bunch of different fabrics that are used in spacesuits, or at least simulants that were close to spacesuits, as well as lunar dust simulants. So, for example, they used things like Kevlar and different types of things called orthofabrics, which are mixtures of different type of fabrics, like Kevlar and something called Gore-Tex, which is water-resistant fabric, and Nomex, which is fire-resistant fabric. NASA also collaborated with them a little bit and provided them a small amount of spacesuit material that they were trying to develop for use on the moon. What the team did was they used lunar dust simulant, which actually is just volcanic ash. If you're in the Pacific Northwest, you may know this fun fact about us. We had a huge eruption of Mount St. Helens back in the day. And apparently a bunch of the ash that resulted from that eruption is just being kept in tubs somewhere. So, you just pop it open, grab some volcanic ash, and then use that as a lunar dust simulant. And the reason why they use that is because it has very similar properties, actually, to lunar dust. It even has like electrostatic charge and like weak magnetism to some degree. But what they did eventually was they took the spacesuit simulant and they took the lunar dust simulant, the volcanic ash, and they would apply it onto the fabric. So they would take the lunar dust, apply it onto a fabric, and then they would put it in a vacuum chamber, spray some liquid nitrogen on it, and then before and after they would weigh that fabric sample, and they were able to compare the mass to determine just how much lunar dust simulant they were able to get off using liquid nitrogen. That's all well and good on like a little swatch of fabric, but how does it actually apply to a spacesuit, which has nooks and crannies and a lot more like technical design considerations? So what they did was they created a 1/6 scale of an astronaut, which was essentially a Barbie doll. These pictures are amazing, by the way. I will post them in the show notes, but they are incredible. They took a Barbie doll and then sewed a mock spacesuit using some Kevlar fabric, and she has a little helmet and everything. They brushed a bunch of lunar dust onto the spacesuit that the Barbie doll was wearing, put her in a vacuum chamber, and then using a liquid nitrogen nozzle, they blasted the spacesuit with liquid nitrogen, and then did essentially the same thing as the fabric swatch test before, where they were weighing before and after to see just how much dust was removed. And surprisingly, this method removes like about 95% or more lunar dust material, which is incredible for something like as simple as liquid nitrogen and as non-abrasive as something like brushes, which we mentioned earlier. So one other interesting thing about this experiment was that you would think, right, when you take the spacesuit material and brush lunar dust on it, it's going to look all mucky and dusty. And then after you clean it with liquid nitrogen, it's going to look sparkling clean. Actually, what happened is, yes, that's true. For the most part, they did several experiments where they just did a vacuum treatment. And then they did another experiment where they did a vacuum treatment and then went in and did spot treatments on some areas that still had dust. You can still see some lunar dust staining that's occurring on the spacesuit. So you still see like some gray patches of lunar dust simulant. And they're still trying to figure out why that is. And it might have to do with some kind of interactions between the dust and the type of fabric that's being used. So there are still a lot of challenges trying to apply this kind of research to an actual spacesuit in the actual lunar environment. Things like, being able to model the complex electrostatic interactions that would be occurring with the lunar dust, the higher lunar vacuum, the higher temperature variability, the reduced lunar gravity, all of these things. But it's very cool research and just like a very cool combination of both Barbie dolls and just highly scientific lunar research. And the team was also recognized by NASA with an Artemis Award back in 2021. And the most recent paper that I'll drop in show notes, if you're interested in taking a look at it, is from February, May timeframe of last year, which was 2023. So the research is still in development, and they're still trying to solve all of the challenges and limitations. But yeah, really interesting stuff. I could talk about lunar dust and Barbie all day, but I won't. I'll spare you.
Lunar dust mitigation Barbie. I love it so much.
This is just Lunar Barbie's world, and we're living in it.
I just wish I could be a fly on the wall when they proposed that idea of we just want to blast the Barbie doll with liquid nitrogen for science.
For science.
Originally, we wanted to talk about this in relation to Shark Week last year, but it didn't work out with the timing. However, with each planet having a different orbit, though, I'm sure it's probably Shark Week somewhere in the universe.
A bit of a technical note here. We haven't actually fact-checked this, but just come along with us for the mental fantasy of it being Shark Week anywhere in the universe. There is actually a really cool software I will drop in the show notes where you can see like what time it is on Mars based on Earth time, but I digress. That's a whole tangent. Just stay with us for this mental journey.
I love how you have presented on like the actual practical constraints of living on the moon or on other planets, and I'm just like, it's probably Shark Week somewhere. We must celebrate accordingly.
I'll believe it. I'll go along for that ride.
But Alexa, to put you on the spot with a pop quiz.
Oh no.
Did you know that whale sharks and stars have something in common?
I do know that there is this interesting fact, that sharks are supposedly older than a lot of things that we know of, like the Polaris star group and the rings of Saturn.
Oh.
So what I have dug up on my, one of my rabbit holes in the past is that, so sharks are about 400 to 450 million years old, and the Polaris star group is estimated to be around 70 million years old. And the rings of Saturn are about 10 to 100 million years old, according to new research from the Cassini probe. So take that for what you will. That's what I know about sharks and the stars, and also that they are both large and beautiful to observe.
I was going to say you went in such a cool, unpredicted direction from where I was going with it, but I love it.
Did I ace the shark quiz?
You knocked it out of the park.
Thank you.
This is so I had no idea. That's so cool. What I was going to talk about in relation to sharks and the stars is slightly more recent. In the 1980s, the Hubble astronomers needed a way to map and compare the configurations of stars in relation to each other that the telescope was photographing. So in 1986, Dr. Edward J. Groth, who was a physics professor at Princeton University, he invented an algorithm that matched patterns to help solve this problem. And how that worked was it would take any combination of triplets of stars, and it would form all of these little triangles between every possible group of stars in threes. Because certain properties of triangles don't change when the triangles are rotated or even resized, the algorithm became an important tool for the astronomers to use comparing different images of stars and mapping out star locations. And while it has since been updated, a version of this algorithm is still in use in the Space Telescope Science Data Analysis System. Say that 3 times fast. Or STSDAS. And it's a software suite that's used to analyze data gathered by Hubble. And it's also, or I saw in my research that it was also in use for the development of the James Webb Space Telescope, but I don't know if it's still in use. In 2002, a software programmer and technical writer, Jason Holmberg, was on vacation scuba diving in the Red Sea, and he encountered a whale shark. And so whale sharks, if you're not familiar, they're the largest shark, which makes them the largest fish on the planet. And so they usually grow to the size of 18 to 32 feet or 5.5 to 9.8 meters. And they're no threat to humans despite their size. They're gentle giants. They're filter feeders that eat mostly plankton, both phytoplankton and zooplankton, such as krill. And then they're also listed as endangered by the International Union for the Conservation of Nature. I just get so excited about whale sharks, guys.
It's relatable.
So he had this beautiful encounter with this animal in the wild. Holmberg begins investigating how to best help the conservation of whale sharks and how to help track and study them. Scientists were having all sorts of problems with tracking these animals in the wild. Physically tagging the sharks for satellite tracking didn't work very well because the tags could be frequently lost or they would break off within weeks. And then another method that the scientists had was plastic visual tags, but less than 1% of those tags were ever spotted again after tagging. Holmberg collaborated with marine biologist Brad Norman at the Australian nonprofit Eco Ocean, which studies whale sharks migrating annually. And Norman had been keeping track of the white spots on the shark's skins because they're obviously massive and they've got like a dark back with all of these white spots on them and then white underbellies. Norman was taking pictures of the white spots on the shark's backs since those patterns were as unique to each shark as fingerprints are to humans. But it was an extremely heavy lift to photo match all of these images with human eyes. And then while investigating different methods and developing an automated way to do this that they could use for this photo matching, Holmberg and a friend working at NASA Goddard, Dr. Zavan Azermanian, who was an astrophysicist with the university's Space Research Association, contracted to NASA at the time, they came upon the Groth algorithm, which provided the perfect blueprint for what they wanted to do in terms of matching those white spots. They modified this algorithm. It seemed especially fitting, as NASA notes in their NASA spin-off blog series, that the whale shark's name in Malagasy, which is the language of Madagascar, is Maro Quintana, which means many stars. And then Geger Lintang, its Javanese name, means stars on its back, or stars in the back. There is a truly wonderful video about this produced by NASA Goddard, which we will drop in the show notes. It's a little bit more compact. It's about 2.5 minutes long, but it's especially helpful, I think, to show what we're talking about in terms of the triangulation of stars and then how it also works with whale sharks. And it definitely highlights how the work NASA completes in space can assist life on Earth. And I think that's actually the theme of the NASA spin-off blog series, is that it shows the work that NASA is doing in space and how it relates to life on Earth. Speaking of how NASA's work is helping study marine life, NASA's PACE mission, which is Plankton, Aerosol, Cloud, and Ocean Ecosystem, the ocean is silent from the acronym there, is launching early February 2024. And its goal is to expand and improve upon NASA's satellite observations of global ocean biology. So aerosols are tiny particles suspended in the atmosphere, such as the dust we were talking about earlier. But of course, we were talking about Earth dust here, and clouds. And this mission will assist in climate studies by providing new opportunities to monitor and respond to changes in our ecosystem. And it's going to also allow us to better understand how our atmosphere and our ocean actually interact. One thing that we did as a group activity prior to this mission launch was the PACE website at NASA. We'll definitely drop in the show notes. They have this extremely cool, well, I don't know, I think it's cool. I'm obviously extremely biased.
I think it's very cool too.
Thank you.
Also extremely biased though, probably.
They have these really cool little quizzes that you can test what kind of phytoplankton you are based off of 4 questions. And then they also have like a really cool matching game that you can play on their website where it talks about the different types of particles, the different types of spectra that those particles would register using the new instruments on PACE, and just how studying them will impact our understanding of the world in a way that's really, really cool. The other cool thing about the PACE mission is that it is a NASA social mission. And by that, it's a NASA social opportunity. And if you're unfamiliar, one really cool initiative NASA does in terms of opening up their communications and their storytelling is that they will designate certain launches or just scientific events as NASA social opportunities. They post about this on their Twitter and on their website. I'll make sure to retweet on the Art Astra podcast Twitter or X account whenever I see one come up. But essentially, NASA socials, you apply if you're a social media user. And if you proceed through the application process and you get selected, you get issued a press credential and you get essentially invited to a NASA official event dedicated to the mission. And more often than not, you get to talk to the mission specialists, you get to tour NASA facilities. It's just really, really cool. I've been on a couple before for Artemis Day at NASA Michoud and NASA Stennis, and the International Astronautical Congress was a NASA social event when it was in DC in 2019. It's just such a cool event where you get to meet lots of like-minded, either science communicators or people interested in science communication from different industries. Just would entirely recommend, and I definitely recommend searching for NASA socials on Twitter and on their website.
Yeah, they always look so cool.
Yeah, and I'm so excited to see what the NASA social participants at the PACE mission event post about.
Hopefully they tell us what phytoplankton they are, because I would love to know.
Right? It's such a cool test. And then I know we did it, like a couple days ago now, but I can't remember the name of my phytoplankton except that it designated me the microchameleon of the sea.
Which is incredible. I think I was like something spiky, like Dictyoca speculum or something. It looks really cool despite its perhaps unfortunate name, but yeah, it's a really fun test.
And then there's also, I know that you were the one who pointed out to me, but they also had this really cool paper model you can make from PACE or of PACE on their website. And again, like it details all of the different instruments and what they'll do and how they differ from previous satellite launches. I just think it's really well done.
Mm-hmm. It's a fun time for sure.
Yeah. Thank you so much for listening and going on so many journeys with us today.
Everything that we talked about today will be in the show notes on our website at artastra.space, where we'll also have transcripts uploaded for each episode as they launch.
If you like what you hear, please subscribe on your podcast platform of choice. Leave a review and tell us what type of phytoplankton you are. If you end up taking the PACE quiz we mentioned, we would genuinely love to hear it.
Actually, genuinely.
Yes. We are also on socials on Twitter/X at Art Astra Podcast. We're also on Instagram, Facebook pages, and Blue Sky. And all of these will also be linked on our website.
Catch you on the flip side.
Don't let the lunar dust get you down.